Question 5a is about the nth term of a linear sequence. There's a couple of ways of looking at finding the nth term of a linear sequence, but the one I'm going to show you is the one that I often use. It's about finding the difference between the two numbers, the first two numbers, the next two numbers, and the next two numbers. This is term number 1, term number 2, term number 3, and term number 4. The difference is 3 each time. The difference between these two numbers is 3. If you were to get from 8 to 11, you'd have to add 3. You'd have to add 3 to get from 11 to 14. You'd have to add 3 to get from 14 to 17. This means this sequence is the 3 times table. Obviously, it's not the 3 times table, but if you were going to start off the rule, you'd put the number 3, and then you'd put it next to an n. The n is the thing that represents the term number. Okay, so if you were to substitute in the fifth term, you wanted to find the fifth term, you'd put a 5 in place of this. Remember, a number next to a letter means multiply. So 3 times 5 would be 15. Obviously, that's not what the next term is. It doesn't fit. There's 2 less than this term. So it doesn't quite work as the rule yet. So there's going to be something that goes on the end. The thing that goes on the end is what we'd call the 0 term. So the term before this term would be the 0 term. If you were to add 3 from this 0 term, well, all you have to do is 8 minus the 3 to find out what that thing is. It's a 5. So it's a positive 5. You're going to stick that on the end of the rule. Now this will work if you want to find the next term in the sequence as well. You'd substitute the number 5 in. You'd do 3 times 5, which is 15, and then you'd add the 5, which is 20, and that works for the sequence. And you know that that's the correct rule because you know that if you were to add 3, it would get you to 20, and that works. Okay, so that's a nice way of checking. B is a lot harder. This is a much higher level skill. It's a quadratic sequence. So it still starts off the same way. You've still got to look for the difference between each of the terms. So I'm going to label the terms. I'm going to put the term numbers in bubbles above each one of the numbers in the sequence that we've been given. So we've been given the number 2, 14, 36, and 68. Now, obviously, this is a calculator paper problem, so you could use the calculator to find the difference between these two numbers if you wanted to. The difference between these two is 12, 2 plus 12. The difference between these two is 22, and the difference between these two is 32. So you could find those. Clearly, that's not the same difference each time. We'd refer to this as the first difference. So when we've got a quadratic sequence, we have to look for the second difference. Now the second difference is the difference that's going to have that number that we're looking for that is the same each time. The difference between 12 and 22 is 10, and the difference between 22 and 32 is 10. The technique when it comes to a quadratic sequence is to half this number and put it next to an n squared term. Because it's a quadratic sequence, we get this squared next to the n. The n still represents the term number. Okay. Now, again, if we were to put 5 in and find out what the fifth term of this sequence is, we do 5 squared, which is 25, and times that by 525. Now, that wouldn't work for our sequence. Okay. So we need to think about what's going to go on the end of this rule. And there's a clue in the question itself, the fact that it's not the final answer. Okay, we've got pn squared plus qn. Now that might seem a bit confusing, but the p is represented by the 5 is represented by the p. Okay, they are the same thing. So we're going to put the p is equal to 5. We found that already. That's going to get us a couple of marks. All we need to do is find out what this value of q is that's going to be next to an n. So to do that, we need to work out what the difference is between the 5n squared sequence and the sequence we were given in the question. So we have to write out the 5n squared sequence. Now, if we did n squared, be 1 times 1, and 1 times 1 is 1, multiply that by 5, that gives us 5. So this is our 5n squared sequence. I'm going to write 5n squared, and our first term in the 5n squared sequence is 5. Our second term in the 5n squared sequence would be, substitute the 2 in, 2 squared is 4, and multiply that by 5, that gives you 20. We're going to substitute the next term number in, 3. 3 goes into the n squared, that's 9, times that by 5 is 45. And then the fourth term would be 16 times 5, which is 80. And then you have to think about the difference between this sequence and the original sequence. So I would write these numbers in the space between the term number and the original sequence that we had. And 80. Now you have to think about what the difference is between 5 and 2. So to get from 5 to 2, you'd have to minus 3. To get from 20 to 14, you'd have to minus 6. To get from 45 to 36, you'd have to minus 9. And to get from 80 to 68, you'd have to minus 12. So we have this other sequence that's going on here. It's all about different sequences. We've got minus 3, minus 6, minus 9, and minus 12. Now all we have to do is work out what the nth term sequence is for this. And this is clearly almost the 3 times table. It's not the 3 times table, it's the negative 3 times table. So the difference between each of these, we're taking away 3 each time. We went from here to here and here to here and here to here. Minus 3, and minus 3. So the rule for this sequence would be minus 3n. That's what we have to attach to the original 5n squared. That would give us our value of q being minus 3.